Okay, so today I am teaching John, KVL and voltage division. So the first half of this video will be KVL. The second half will be voltage division on a different problem. But the one equation you need to know, thank you for that, John. The one equation that we need to know is this one, right here. The sum of the voltages in the loop is equal to 0 every time, which I think is actually pretty cool. So we'll do V1 first. And that one's simple. That one's pretty small. I'm sorry. We're gonna do, so we can pick any direction that we want to go. We can either go this way or this way. Doesn't really matter, as long as we have the signs correct and we are consistent with it. So I'm going to go this way, and I'm going to say that if we go from a negative to a positive, it's positive. And if we go from a positive to a negative, it's negative. And so for this first mesh, we're going to go this way, right? We're going to study this little half circle. And so a positive V1 minus 5 volts minus 6 volts, right, equals 0. Right? Yeah. So that means V1 equals 11 volts.
Pretty easy.
Yeah, the first one. The second one, and I want to add this. So the loop that you should choose is a loop that contains an unknown and only one unknown. I'm sorry. Do you have a question, Adam?
Yeah. So
What's
with
up?
like V4 up top, so
Yeah.
that would be 7 then?
Yeah, it would be.
Dang, yeah. Cool.
I think so.
All right.
Yes.
Give or take time.
We'll get there.
All
But, so, I'm sorry. I don't know what's so funny. I'm sorry for people watching back home. So, well, you know what, Adam? We'll do that one. We'll do V4
Alright.
right now.
Beans.
So V4, we're going to do that half circle up top, and we're going to go this way. So a negative V4, right? A positive 6 and a positive 1 is going to equal 0. That means V4 equals, Adam, 7 volts. Okay, so we'll do V2 next. We're gonna do this square right here, Adam and John. So we'll do it in green, and we're gonna go this way.
So we're going to find V2.
Correct. So positive V2, because it goes from a negative to a positive, minus 9, minus 7,
Plus V1, so plus
plus
11.
11
That
equals 0, which means
It's negative 16 plus 11, so 5,
should be 6.
6,
No, 5. V2 is 5.
something like that.
Right? Because we'll have a negative 16 plus 11 equals 0. Right?
Yeah, 5.
So 5. Equals 5 volts. And then for our V3, we'll do this square right here, and we'll go this direction. So a positive 9, a positive V3, a negative 7, and a negative 3. equals 0. Our V3 is going to be 1. Correct?
Yeah.
Because it'll be -1 plus V3 equals 0. Add the 1 over. Yeah. So that right there is the KVL version of KVL/voltage division. Okay, for the second half of the video, we're going to do voltage division, like I said. And so this is the equation that we're going to be using for voltage division. And what we're going to be doing is we're going to be finding the voltage across this resistor, V2, and the voltage across this resistor, V1. And so first thing we need to do, it works a lot like current division, which is a video that I have made previously. I'll put the link to KCL and current division down in the description. But the equation is very similar, like I said, except these are voltages, obviously, and these are resistances. And so what we have to do for the denominator is we have to find the total resistance, right? And what we have to do for the numerator is we have to find the resistance that is dealing with our component, which is V2, and the component that we're going to specify first is V2, and so that would be these three added up would be Rn, and so I'm gonna add these up quick. 18 and 54 are in parallel, so the total resistance of those two together is just 18 plus 54, which is 72. All right, and so now this resistor, right, is 72 is in parallel with this resistor. So we have to add up 1 over 72 and 1 over 36. And when you do that math, you're going to get 24 ohms. And so what we have here, I'm going to erase this quick. So what we have here, essentially, is a 24 ohm resistance and a 16 ohm resistance. So what we're specifying is V2 first. And so V2 is going to equal R2, which is these three resistance added up, 24 over the total, which is 24 plus 16 times the voltage source, which is 80. Right? When you do that math for V2, you will get 48 volts. And so V1, we can ignore this half, right? So it's just these two resistances, or resistors, and the equation, when you solve it for V1, you're going to take the resistance of the resistance of the component we're specifying, which is 18, over the total, which is 18 and 54, and multiply that by the current. I'm sorry, not the current, the voltage source, that Vs over there on the equation, which is, in this case, 48, right? Because we defined V2 as 48 earlier. So then V1, So that, my friends, is that's V2, 48 volts. That's the voltage jump. So if we define this as the ground, right, then that whole node is 0. And this node is going to be 48 because there's a voltage jump of 48 and a voltage jump over there of 12. And so that is the voltage division example of this unit.